Okay, today we're going to look at section 5.8, definite integrals applied to area and other problems. So we're looking at applications. We've been doing definite integrals. We've looked at a few applications, but we're going to look at some things today that are a little more challenging, a little more specific in what they're able to do, and things that probably we never thought we would be able to do with our calculus. So we want to examine the applications and then use them to find area between curves. We're going to start with area problems and then move to some other things as we get into it. Okay. First thing, we're going to review a U substitution problem. If you're looking at this one right here, then you should be able to recognize that your denominator is what you want to set U equal to. So therefore your du is 2x minus 4 dx. Okay. Well, that doesn't quite match up with what we have in the numerator, but if I factor a 2 out, then it will, and I can move the 2 over. So I have 1/2 du equals x minus 2 dx. Okay, now that is going to take care of everything. The x minus 2 dx is right here and right here. My u value is right here, so we're in good shape. So I want equals. Remember the 1/2 from down here will go in front. Integral. And then the x minus 2 dx is a du. So basically what I end up with is a 1 over u to the 1/2. du. Well, easier way, let's make that the integral of u to the negative 1/2 du and integrate that. That would give me, this would go to a positive 1/2, don't forget. I'm looking at this right here. You add 1 to your exponent and divide by that. So that will go to a positive 1/2, flip it, you get a 2, multiplied times your 2 out in front. And those 2's would end up canceling. So you've got u to the 1/2 plus c, and your u value go back and plug in, and so you have x squared minus 4x plus 2 to the 1/2 plus c. That's it. We're good to go. Okay. We've got several applications, and you can look on page 237 if you want to see a few things there. Displacement we know, total distance we know if we're looking at the absolute value. Area under a curve is another way that we use applications of integrals. Work problems, we'll do a few of those, not a ton because there's not a ton on the AP exam. And then there's several other things. Okay, let's start with area between two curves. This is find the area bound by the graphs of y equals 2x plus 1, y equals x e to the negative x squared, x equals 0, and x equals 2. So I have this picture here. Y equals 2x plus 1 is my line up here at the top. Y equals x e to the negative x squared is this nice little curve going right in through here. Okay, now we've done the area under one curve, like under y equals 2x plus 1, but we have not ever done the area in between, this shaded area. And then we're bounding it from 0 right here to 2 over here. Okay, so that's what my graph looks like. If I find the area under y equals 2x plus 1, that would simply be integral from 0 to 2 of 2x plus 1 dx. That finds the whole area under the curve. But this piece right here does not need to count. Okay, so I would need to subtract that area that is under the curve x e to the negative x squared dx. Okay. Well, a lot of times what we do on these is to combine it into one. You can do it certainly in two separate integrals, but because they both have the same bounds, most of the time what we'll do is an integral from 0 to 2 of 2x plus 1 minus x e to the negative x squared dx. And basically, that's all there is to it. We're just going to integrate this. So I'm going to integrate this piece right here, this first part, and I'll have x squared plus x going from 0 to 2. I'm going to hold off integrating this last piece for just a moment, okay? Because what I want to do with it is come over and do u substitution. Okay, let's set u equal, excuse me, let's switch pens for a moment. U equals negative x squared. So then du is negative 2x dx. I do have the x in the front there, so I'll move that negative over. That'll be a negative 1/2 du equals x dx. And that makes that match up nicely. So that becomes right in here. I'm going to still do it in the green so that you can tell that I'm doing the second part, this part right here. So that's going to kind of, one more time, that's going to become a plus because of the minus right here and the minus right here. So that's going to become plus 1/2 the integral of e to the u du. Okay. So continuing on, sorry about this, I'm kind of running a little bit out of room. I have x squared plus x going from 0 to 2 plus 1/2. The integral of e to the u is e to the u, so let's just put this back in and we'll have e to the negative x squared going from 0 to 2 was what we originally had. Okay. So there we've got that. Go through, plug in your numbers on this. I'm counting on the fact that we're in pretty good shape since I'm running out of room here. Plug your 2 in and you've got 4 plus 2. And then remember we always subtract with the 0 plugged in there, which is 0 plus 0. Plus, moving to this next one, we've got a 1/2. And then that's going to be e to the negative 2 squared, so e to the negative 4. And then you plug in your 0, so minus e to the 0. Okay. Hopefully, as you go through and do this, 4 and 2 is 6. Plus 1 over 2 e to the 4th. And then e to the 0 is a 1, but times the 1/2 in front, so minus 1/2. So 6 minus 1/2, and we get 11/2 minus 1 over 2 u. And hopefully we're good with that. If you need anything, be sure you let me know tomorrow because I did kind of crowd that up a little bit. Okay. Sorry, we're going to skip this one for a moment and go to this page right here. Okay. And what I want you to see on this is that on the one like we just worked, we had a top curve right here, and we had a bottom curve right here. Technically what we were doing was coming in and making, you remember those rectangles that we made? We were making a bunch of little rectangles, and we were adding all of our little rectangles together in order to find the area between those two curves. When you are doing this, if you are drawing that rectangle vertically, then your integral will always be integral from a to b of the top minus the bottom function, where a is the left bound and b is the right bound. In other words, this right here is your A, and right here, that is your B. Okay, so if you have a vertical rectangle, it's going to have to be added from the left to the right. So that's why you have your A and your B. Okay. Now then we'll do one here in a minute where you have to do a horizontal rectangle. And when you do that horizontal rectangle, that means you're coming in and looking like these. Okay, over and over on these spaces. When you do that, that's a whole different deal. You want to do right minus left. It has to be done in terms of dy, which means your C and your D right here are your values here. So when this comes over there, that is your C value. And when this comes right here over to here, that is your D value. And so those like that, if you have a horizontal rectangle, have to be done everything in terms of Y. C is your bottom bound and D is your top on that. We will look at that again tomorrow. This is not the only time you'll see this. So just be ready, because we will definitely use that quite a bit. Okay, so we want to, excuse me, we want to go back to this one with the intersecting areas. A little bit bigger picture than what you were looking at before, and so I want us to be sure that we understand this one completely. In order to figure out what my boundaries are, I can tell right here, -2 is going to be where I'm starting, 5 is where I'm stopping, and yes, I'll agree that probably I could guess that I'm going to be changing, you know, that my blue line switches from the bottom to the top at -1, and at 3 it switches back underneath again. But in order to double check that, what you need to do is set those equal to each other. If you set 2x squared plus 10 equal to 4x plus 16, then overall you've got 2x squared minus 4x minus 6 equals 0. Factor out your 2. Continue to factor. And you can tell that your intersection points are at 3 and at -1. And so that's how you found those bounds. Well, if I want to find the area of this, all 3 pieces, I can't do just a top minus bottom because the top and the bottom keep changing. Okay, so if you've got one like this, you have to break it into pieces. Okay, this right here is going to be my first piece. This right here is going to be the second piece. And this up here is going to be the third piece. Okay, so this gapping right here will be third. This will be the piece that goes in the middle. And this over here will be what we'll start with. Okay. I'm just going to set it up because y'all can integrate now. We're getting good enough at that we should be good. So this would be the integral from -2 to -1, because that's the whole width of that space right there. The thing that is on top right there is the parabola, 2x squared plus 10 minus the line 4x plus 16 dx. That is the first piece. Okay. Plus, okay, and it's going to be kind of lengthy again, so I'm running out of room. I'm going to drop down to the line below it. Integral from -1 all the way over to 3, because for that whole length, the line 4x plus 16 is on top. And remember, it's always top minus bottom. We just looked at that picture. So the top is 4x plus 16 minus the bottom 2x squared plus 10 dx. And that should have been done in green. So sorry. How about if we change this? This is my nice little red piece. Right there. And then up here, this will be figuring. All right. So, all fixed up. Again, it's going to be lengthy, so I'm going to continue on again. This is an integral. It goes from 3 to 5. That's how the width of that piece right there. Again, we've switched back and our parabola is on top. So I am back to 2x squared plus 10 minus 4x plus 16. Top minus bottom always. And then you just go through and integrate each piece, plug in your numbers, test it out, see what you get. We'll double check in class and make sure our answers all match up. But that's the way that one should be set up. When you've got these on a test, you want to be sure you set your functions equal to each other right here so that you can find the intersections and know how to integrate this. Okay? Easy, not a tough thing at all. This one we're going to save and do in class because I want to show you how to do do it vertically or horizontally and which way is better and how to decide. So we'll work on that one a little bit later. Back to our pictures. Don't forget, if it's going to take vertical rectangles, you want top minus bottom with your widths going from the left over here to the right over here. If you have a horizontal rectangle, then you want to go from bottom right here to top. Okay? Rectangles laying horizontally or lying horizontally. Okay? Everything on this second one is done in terms of Y. Big deal. Everything on the first one is done in terms of X. Things that you've got to get down, be sure you've got this copied down in your notes. All right, homework, onward we go. Bye.